Hi everyone. In this video, you will see in continuation with previous video, we'll see how does shuffling works in Spark and what does AQ bring to the shuffling mechanism and how does AQ coalesces the partitions after shuffle so that we don't run many IO intensive task, right? And finally, we'll also conclude when not to use AQ, right? So first, I will enable the disk cache. So this will ensure that the queries are getting executed faster when I run. Okay. Now loading the sample data. The sample data which I used is the same as I used in the previous thing. So you can go to the Spark Open dataset and here you will be able to get the description. So they are loading the data and I'm filtering for certain years. To see here there is a filter and let us load the data. Okay. Now first we need to see whether AQA is enabled. So in all Spark versions in Databricks, currently AQA will be enabled. That can be checked using this property. So once you enable AQE, we can also check the same thing using a config. So this is something which has been regularly asked to me. How can we set or update the property? So you can use the set statement as here, or you can also use your spark.conf and then you can set the values and get the values. So let us do a limit 10 of the data set, right? So one key thing to note here is AQA will work only when there is a shuffle. So what that really means? So that means let us run a simple query, right? So this is a simple query where we are displaying the data, right? So if I go and check the Spark UI, you will see here there won't be any AQA enabled, right? Like it is similar to what we saw earlier, right? We see the data getting read and it is converting to row and then it is limiting out the 10 records, right? So that is one of the key things which we have to keep in mind. So typically, right, when we load the data set, assume like you read the data and write back to a target table without any operations which involve a shuffle. Say you don't use any distinct or a group by or any action which involves a shuffle, then AQA doesn't get operated. So that is where you can do your traditional coalesce, df.t partition or df.coalesce. So that is still operational even if you have AQA enabled. If there is no shuffle, you have to use the coalesce or repartition. So now let us see the concept of shuffle exchange, right? So when we do a shuffle, right, or when does the shuffle happens? So when we do a group by, right, where it cannot get all the data and then load in a single place, right? So now when we do a group by, it has to bring all the data of a particular vendor ID, right? Say vendor ID 1 into one groups, right? So whenever you do that group by operation or any other function similar to group by, say a distinct or you do a row number with partition, so everything will involve a shuffle. So if you see here in the plan, you will see this exchange happening and it is doing a hash partitioning, meaning for default numbers, right, hash partition will be just the modulo of the number. For example, if I have a value of say 100 and the default 200 partitions are there, when I do a modulo, so you get the 100, right? So if I have say 101, it will go to the like 101 partition, right? Say I have a vendor ID of 300 and maybe 375, right? Then it will go to the 175th partition, right? So this is the hash value, right? Similarly for string, it will try to use the hash value and based on that it will try to group the data into 200 partitions. So for each partitions, typically a shuffle will be or a stage or a task will be running in the backend. So the more the shuffle is happening, the more the 200 task stages are getting generated, the more problematic it will be, right? So let's disable the AQE so that you will know like what kind of a problem it is. So I have started the run. Let it run. I will fast forward it and then I will show the diagram. Okay. Now the query has come. Let us see the explain plan. So let us, as usual, go to the SQL tab. So let's see what has happened. So as usual, it has read the data and you will have the blue color boxes. So which is like a whole stage code. So these are basically the stages and the first stage consists of it reads the data, it converts the rows to columns and we do see a tiny aggregate here. If I go and hover over it, you'll see like a partial count. So what basically essentially it is doing is it reads the data from the 17 files or the partitions and within that it just try to do a mapping. Say for vendor ID 1, like for each vendor ID, it will try to get the count. So it will do an aggregate within the partition. So this doesn't need a shuffle because within the same partition or in the same executor, it is trying to do a group by aggregate and then get the value. Now once it does the aggregate, this is our main partitioning which we saw earlier, right? So you could see it is having 200, right? But if you go and see the data size which is written and then the data which is being written right after the shuffle it is very less. It is around 2.4 KB in total here and then 1000 KB, right? So the rule of thumb is generally 128 MB to 200 MB is what, which is the allowed size per partition. So we are having a very less size, right? But still, why it is taking 200 is because of this property. So what this will do is, if you see here, the default shuffle partitions is 200. So whenever you have a query which involves a shuffle, by default it will take 200. So what we can do is, since we know in this case our estimated size is very small because we are just doing a count. So let us set the shuffle partitions to 1 and let us do a display now. Okay. Now it took around 13 seconds. Let us see why. Number one, right? If you see here, we have the disk cache enabled. So it did a local scan of the data and it does the partitioning or it does the internal aggregate. Like say for within each of the partition, it does aggregate. It doesn't involve the shuffle because it just takes the data. Say it reads one file and within the same executor, right, it can just do a count. Now if you see the exchange here, right, you will see it is taking around the number of partitions are 1, right? But the same data size is read and the same is being written as well, right? Now let's do one thing, right? In this case, since we know confidently that the data shuffled is very less, we can very well go and set the value of 1, right? So what if, right, we don't know this concretely, right? So that is where a key comes into play. So let's enable a key and let us again switch back to the default 200, which was set to 1 earlier, right? So let us again do a display now. Okay, now go and see what AQ has done potentially to the output. Okay, so how can you know, or how will you know AQ has been executed to this query? You will see the last node, which will have this adaptive Spark plan execution is equal to true, right? Now let us see the same steps, right? So it has read the data, it has converted to column, it has done the aggregation, right? And after that, once we have an exchange, right? If we go and check the previous query's execution, say without your AQE enablement, so there is the query without AQE. So in this, what will happen is once it does the exchange, so it assume like you have 200 partitions here, right? So within each of the partitions, it will try to get the, or it does the final merge, or it executes the query with these 200 partitions. And when it does the limit one, again it executes on the entire set of partition, right? So what does AQ exactly does here is, whenever there is a shuffle, say here it is set to 200, right? Once the stage is done, it will introduce a new stage, right, which is known as AQE shuffle read. So what it will do is it will estimate the size from the previous stage. So it is approximately 2.4 KB, right? So instead of executing the remaining piece of code, right, on all the partitions, it will does the collage and it will do the next set of steps on these collaged stage. So basically, we are not executing right 200 aggregating the data from 200 shuffle partitions. Rather, it will coalesce it to 1. So we are basically trying to reduce the size, right? And then it will do the aggregate. And finally, there is one more option. So we can set the shuffle partitions to auto. So what does this really mean, right? So in both the queries, right, we saw it was setting the default value of 200, and from there it is coalescing for the next steps, right? So when we set the shuffle partitions to auto, so what it will do is basically, instead of taking 200 partitions and then coalescing it, it will basically take a nominal value, and you could see the AOS shuffle which has been set. So if you could see, instead of we setting the value manually, it will basically take a nominal number. Instead of taking 200 default value, it will choose a nominal value, and based on the nominal value, it will do the exchange, right? So let us quickly check the timing of these queries, right? So it took 11 seconds with auto shuffle, and with AQ enabled, it took around 23 seconds, and without AQ enabled, right, it took just 13 seconds. Okay. So the thing to conclude here is, if you know very well, right, that only one you are going to have very less amount of data, then very well you can go ahead and set the shuffle partitions to a number, and you can disable or you can stop the AQ, right? Because AQ will additionally introduce one more shuffle read where it will go and read the shuffle data, and based on that it will coalesce. But whereas when you set the value to 1, it automatically knows that, or it automatically forces the Spark to only run only one exchange with only one executing task, meaning it will bring all the data. Instead of bringing it into 200 different partitions, it will bring it to one, right? So in this case, right, what we understood is AQE enablement will not solve the issue in all the cases. So very well, if you know the data size and this is how you're going to query your data, you can set the shuffle partitions so that it will work automatically. Now we will see where AQE will shine, right, or where you want to enable AQE, right? So I will again disable the AQE, and I will also set the shuffle partitions to the default 200, right? Now we have a query where I'm doing the filter, and to involve multiple shuffle stages, I'm doing one partition on vendor ID and then one more group by on passenger count, and then I'm taking the count. So let us run this query. So yeah, I'll take and explain, and probably, right, let us go through the Spark DAG itself, right, so that it will be easy to explain. So let us run this query. So as you can see here, you will see a reading phase, and then there is a shuffle, or your 200 task stages is getting. Okay, now the output has come. Let us see the query plan and the execution. So in our SQL query, what did we had is we did a row number function, we partitioned by vendor ID. So this will involve one exchange, and we are also doing a group by and passenger count. So this will be having two exchange. So if we go and see here, from the bottom up, it is scanning the data, and then the second phase is it is basically within the scan data, it is ordering by vendor ID and the pickup time descending for the window aggregation to pick up. And once it does the ordering, it does an exchange. So by default, right, the exchange is having 200 partitions. So you could see here 200 partition stage will be there. You could see the 200 task stages are getting executed. And once it does the exchange based on the vendor ID, so you could see, because we are partitioning by vendor ID, it does a hash partitioning on vendor ID. It again does the ordering, and this is where it will do a grouping. So this is an optimization which is done so that if you have a very high window functions, right, say you have millions of rows, within a single partitions to avoid issues in computation. It will group it and then compute the row number. Then we have the running window function. This will have the row number, or it will have your row number ascending assignment, and then it does the partial aggregation for the passenger count, right? And then we will see here one more exchange. So in this exchange, the data read is around 240 bytes, right? Whereas in the previous exchange, right, here the data is around 370 KB, right? And how do we basically then set the shuffle partitions, right? And if you, one more indication is you can also check the text execution summary. So it will give exactly how much time it is spent on each step, right? So you could see the shuffling pieces are not taking much time, but whereas in the initial group by queries it is taking time, or initial window functions, right? So the idea here is basically whenever you have multiple shuffle operations and when you don't know exactly, right, to set the values, see I can go again here and then set the shuffle partitions to 1, right? But this will again will not solve my problem because I have to read it, or I'm doing multiple group bys, right? So that is where what we can do is we can allow the Spark to take the control, and we can, and then now let us fire the same query, right? Let us see how much better it is giving now. So in this case, we are given the full control to Spark. And one more key thing to note here is always shuffle alone will not cause a problem, right? We need to see. So in this case, most of the time is spending on reading the initial data, right? Because the initial data is not sorted on any particular column. It is spending a lot of time in just reading the data. Whereas in the shuffle, it took around 4 seconds here and then 2 seconds over here. And there are again one more exchange where it is having a 200 task in this phase, because for every exchange, as I was saying, right, we have not coalesced anything, right? Or there is no AQV kicked in. So it will take this. See, initially it had 17 partitions, 17 tasks are running. Then it had 200 when it does the first shuffle for the windowing by window ID. Again, it does carry, basically it uses the same partition. So even though the data here is pretty much less, it will again go with the same number of partitions here, and finally it will do the aggregation, right? Now let's see with our AQV enablement, right? How does this reduce? How can you check whether AQV is running, right? You could see here the functions, right? You could see the blue and gray boxes. So this is also kind of one of an indication to say whether AQV is enabled or not. And you will see sometimes multiple versions of the plan here to show that it is updating even the rest of the complete execution in case of a complex tag, that EQ is adaptively executing it. Say you have a query with a group by and then a join. Based on the group by output, it will probably regenerate a new plan. So that's why the other portions are grayed out. So whatever it is blue, it means it has taken this route and it will start executing. And once it does this particular piece of exchange, it will have the AQE shuffle read kicking in. And based on that, it will take a call whether to go with the current plan or a modified plan. Yeah, now the output has come. Let us see what is AQE has done here. So one significant improvement you could see is, right, earlier it was taking around 17 minutes. We could see, right, it was around 17 minutes here, and it is around 6 minutes overall here. So let's see what is the changes it has brought to our execution plan. Let us compare it side by side. If it is reading the data, then it has done the similar operations as earlier, and you will see the first exchange. So it, based on this, right, if you see here, it has understood the required number of partitions, and you could see it has set the number of partitions as 943. This is probably because of the window function what you have said. It is able to detect the ideal number of partitions, and once it takes the number of partitions automatically, it then does the coalescing, right? So AQE auto shuffle partitions, again, it is an estimate, so it can go wrong. So once it takes a number based on the stats which is collected here, it understood that one partition is more than enough for the data set what we are doing in the window function. And since it is reduced to one partition, you could see here all the things, right, are executing within one partition, right? And once it gets the aggregate, again we need to do a group by on the passenger count. So for this, it estimates 16 as the number of partitions, right? And what it will do is it is again coalescing it, since it feels like based on the data volume, one partition is more than enough, and finally it is giving back the output. So now if we go and see the time taken, if you see here, earlier it was taking a lot, around 50 minutes on the data set. Now this has reduced to 45 minutes, and you could see significant, right? You don't see anywhere the partitions are 200, right? So it has pick up and executed the things with just one partition, right? And it is giving us the final output. So the key takeaways here are, how does AQE enablement helps us in overall shuffle reduction? Because it has a couple of properties. One is adaptive query execution enablement and shuffle partition set to auto. So these two properties will combine basically, and Spark will does the exchange very first time. So by default it is 200, and with the auto partitions, it will use the stats and come up with a number based on a formula. And finally, it again coalesces it after every stage whenever there is no when it determines that after the shuffle is happened, it checks whether the data which is there in each shuffle node, if it is like of a record size probably of 128 MB. If not, it will coalesce it to single partition. Then it does the aggregation, right? So if you see here, the aggregation is done predominantly after it does the coalescing. So there is a AQ read that then only it is doing the aggregations, right? So here as well as in the above one, right? So before it does the aggregation here, right, or when it is merging the count, it ensures that it is doing the coalescing so that it doesn't overuse or it doesn't create many tasks for the IO consumption. So that's all for the day. Thanks everyone. Please do subscribe and share if you like the video.